Have you ever wondered why the sky becomes so dark after sunset? It feels almost impossible when you consider what scientists have discovered. According to modern astronomy, the universe contains an unimaginable number of stars. Not merely millions or billions, but countless trillions. So why isn't the entire sky flooded with their light? Why does darkness still surround us? This seemingly simple question puzzled some of the brightest scientific minds for more than 200 years. Eventually, researchers uncovered the explanation, and it completely changed our understanding of the cosmos. As remarkable as the mystery itself may be, the real answer is even more extraordinary. At this very moment, you exist within a universe containing far more galaxies than scientists once believed. Not just a few more, or even twice as many, but at least 10 times the previous estimates. Even more astonishing, astronomers think that nearly 90% of all galaxies remain beyond our view. They are there, yet they cannot be seen. So the next time you look up at the night sky, keep this in mind. You are not staring into empty space. You are looking toward the greatest hidden region in the universe. And once you understand the reason behind it, you'll never see the night sky in quite the same way again. For thousands of years, people assumed the stars were all there was. Those distant points of light seemed endless. Ancient civilizations built myths around them, relied on them to navigate across the seas, and used them to track the changing seasons for farming. The stars played an important role in shaping human history. As telescopes became more advanced, astronomers discovered more and more stars. Every new generation of instruments revealed objects that had previously been invisible, making the universe appear larger with each discovery. Yet one fundamental question never disappeared. If the universe is filled with stars, why is the sky dark? Although it sounds straightforward, questions like this often prove to be the most difficult to answer. Picture yourself standing in the middle of an immense forest. Trees surround you in every direction, stretching as far as you can see. No matter where you look, another tree blocks your view. Now imagine replacing every tree with a star. If the universe were infinite and stars existed everywhere, then every line of sight should eventually end at a star. The entire sky should be shining. There should be no such thing as night. And yet every day, darkness falls once again. This mystery eventually became known as Olbers Paradox. For many years, no one could find a convincing explanation. One proposal suggested that enormous clouds of dust scattered throughout space were absorbing the starlight before it reached us. Since dust on Earth can block sunlight, the idea initially seemed quite reasonable. However, there was one major problem. Dust cannot continue absorbing light forever. Over time, it heats up, and once it becomes hot enough, it begins to emit its own radiation. Even if that radiation were invisible to the human eye, sensitive telescopes would still be able to detect it. Because they did not, the idea could not explain why the night sky remains dark. The question remained unanswered. The universe continued to guard its greatest secret. Then a breakthrough changed everything. It wasn't the discovery of more stars that transformed our understanding. It was the realization of something far more profound. The universe itself had a beginning. For centuries, many believed the cosmos had existed forever, with no starting point and no ending, an infinite expanse stretching endlessly in every direction. But new scientific evidence overturned that belief and completely reshaped our view of reality. Welcome to Hubble. We've noticed that around 91% of the people who regularly watch our videos haven't subscribed yet. If you enjoy the content we create, please consider subscribing. Your support helps the channel grow, allowing us to bring you even more fascinating videos. Current scientific evidence indicates that the universe is approximately 13.8 billion years old. While that figure is almost beyond comprehension, it reveals an essential truth about the cosmos. Light does not move instantaneously. Although incredibly fast, traveling at roughly 300,000 kilometers every second, it still requires time to cross the vast distances of space. When you look at the moon, you are seeing it as it appeared about 1 second earlier. Looking at the sun means seeing it as it was roughly 8 minutes in the past. Observe a distant galaxy, and you're witnessing light that began its journey millions or even billions of years ago. The farther away an object is, the farther back in time you're looking. In that sense, The universe acts like a natural time machine. Every glance into deep space is also a glimpse into cosmic history. This changes the picture completely. Because the universe has existed for only 13.8 billion years, light from the most distant regions has simply not had enough time to reach Earth. Those galaxies may already be out there, but the light they emitted is still traveling across space. It hasn't reached us yet. Think of it like receiving a letter from someone far away. Until the envelope arrives in your mailbox, you cannot read what's inside. Not because the letter doesn't exist, but because it hasn't reached you. The same principle applies to the universe. Countless galaxies may already be sending their light toward us. We're simply waiting for those signals to arrive. That solved part of the puzzle, but it wasn't the complete answer. Soon, astronomers uncovered another remarkable clue, one that was even more unexpected. The universe is expanding, not expanding into empty space, but expanding as space itself grows. Every second, every minute, every day, the fabric of the universe stretches farther than before. Imagine drawing several dots across the surface of a balloon. Now begin inflating the balloon. As the balloon expands, every dot becomes farther from the others. The dots themselves are not moving across the surface. Instead, it is the balloon that's getting bigger. The universe behaves in much the same way. Galaxies drift apart not because they are traveling through space, but because space itself is continuously expanding. This expansion also affects the light those galaxies emit. As the fabric of space stretches, the light traveling through it stretches as well. Its wavelength becomes longer, causing its color to shift toward the red end of the spectrum. Given enough stretching, the light eventually moves beyond the range visible to the human eye. It doesn't disappear, it simply becomes undetectable to us. A similar effect can be experienced with sound. Imagine an ambulance speeding past you. As it moves farther away, the pitch of its siren drops because the sound waves are being stretched. Light follows a comparable rule. As distant galaxies move farther away due to the expansion of space, the wavelengths of their light become longer. Astronomers refer to this phenomenon as redshift. It stands among the most important discoveries in modern astronomy because it revealed something extraordinary. The universe is not static. It is constantly evolving, continuously expanding, and never remains the same. Yet the greatest surprise was still to come. When scientists finally uncovered it, they realized that their estimate of the universe had been dramatically incomplete. For many years, astronomers believed they had a reliable estimate of the number of galaxies within the observable universe. Their calculations suggested a total somewhere between 100 and 200 billion galaxies. Even that figure seemed unimaginably large. After all, a single billion is already difficult to comprehend, making 200 billion appear almost limitless. To most people, the question seemed settled, but science rarely stays still. Time and again, new discoveries force us to rethink what we thought we understood. That's exactly what happened here. Researchers returned to the data with fresh methods and more powerful analytical tools. Rather than relying on a single snapshot of the cosmos, they examined decades of astronomical observations. Images captured by the Hubble Space Telescope were carefully analyzed alongside newer discoveries, while advanced computer simulations were used to estimate the enormous number of galaxies too faint or too distant for Hubble to detect directly. The conclusion stunned the scientific community. The universe contained far more galaxies than previous estimates had suggested. Not just a modest increase, and not merely double the original count, but at least 10 times more. This pushed the estimated total number of galaxies in the observable universe to roughly 2 trillion. Take a moment to think about how enormous that number really is. 1 million seconds passes in about 11 days. To put these numbers into perspective, 1 billion seconds equals almost 32 years. Stretch that to 1 trillion seconds, and you're looking at more than 31,000 years. That's the scale we're dealing with. And the estimate isn't 1 trillion galaxies, it's around 2 trillion. Each of those galaxies may contain millions, billions, or even trillions of stars. Our own Milky Way, for example, is home to hundreds of billions of them. Now imagine multiplying a galaxy like ours by trillions. The sheer scale becomes almost impossible for the human mind to comprehend. Yet another astonishing realization was still waiting. Astronomers discovered that the majority of these galaxies had never actually disappeared. They were simply beyond our ability to observe. Scientists estimate that roughly 90% of all galaxies are either too dim, too distant, or too small to be clearly detected with the telescopes available today. Picture yourself standing on a beach as the sun sets. The boats closest to shore are easy to see. Those farther away become tiny specks on the horizon. Eventually, the most distant boats vanish from view altogether. They haven't ceased to exist. You've simply reached the limit of what your eyes can detect. The universe follows the same principle. Although modern telescopes are extraordinarily powerful, they are not limitless. Light from many remote galaxies has traveled such immense distances that it has become extremely faint by the time it reaches us. In other cases, the expansion of the universe has stretched that light into the infrared part of the spectrum. Infrared light lies beyond the range of human vision, and even many astronomical instruments struggle to observe it effectively. It's similar to trying to hear someone whispering from the opposite side of the planet. The sound may exist, but it can never reach your ears. This is why vast regions of space appear empty. In reality, they are anything but empty. They are filled with galaxies that remain invisible to us, hidden not because they are absent, but because current technology cannot fully reveal them. This discovery also forced scientists to rethink another long-held assumption. For many years, galaxies were thought to remain relatively unchanged over time. Today, we know that they are constantly evolving. They expand, transform, interact with neighboring galaxies, and sometimes even combine into entirely new systems. Imagine two soap bubbles drifting through the air. As they gently meet, their surfaces merge, forming a single, larger bubble. Galaxies follow a process much like this. Across billions of years, gravity gradually draws them toward one another. When they finally meet, they don't collide in a sudden, violent impact. Instead, they slowly blend together, forming a single, larger galaxy through an incredibly long and gentle process. These events unfold over millions of years. There are no massive explosions or dramatic crashes, only a slow gravitational dance taking place on a cosmic scale. Our own Milky Way has experienced this before. Throughout its history, it has absorbed several smaller galaxies, becoming larger with each merger. And that process is far from over. Roughly 4 billion years from now, the Milky Way will begin merging with the neighboring Andromeda galaxy. When that happens, the appearance of the night sky will be unlike anything we see today. Even during this enormous event, individual stars will remain separated by immense distances. Nearly all of them will pass one another without ever making contact. Over time, however, the two galaxies themselves will gradually unite, creating one much larger galaxy. This also reveals something unexpected. The universe actually contains fewer individual galaxies today than it did billions of years ago. Early in cosmic history, countless small galaxies filled the universe. As time passed, gravity caused many of them to merge, producing the larger galaxies we observe today. Imagine constructing a castle from thousands of small building blocks. At the beginning, you have countless separate pieces. As construction continues, those pieces become part of one enormous structure. The number of individual blocks decreases, while the size of the finished creation grows. The universe has followed that same pattern for billions of years. This is why astronomers believe the young universe contained far more separate galaxies than exist today. Every galactic merger preserves another piece of cosmic history. Each collision adds another chapter to the story of the universe. The cosmos is never motionless. It is constantly evolving, and that transformation continues every moment above our heads. But if nearly 90% of all galaxies remain invisible, how can scientists be confident they exist at all? How do you measure objects that you cannot directly observe? The explanation is one of the most remarkable scientific investigations ever carried out. Its foundation lies in interpreting the faintest signals carried across the universe by light. Astronomers do not rely on assumptions. They gather evidence, analyze it carefully, and repeatedly test every conclusion. In astronomy, light provides the most valuable evidence of all. Nearly everything humanity has learned about the universe has come from studying the light that reaches us. Every star, every galaxy, and every cloud of cosmic gas emits light that travels across the universe. That light is far more than simple illumination. It carries valuable information. By studying it, astronomers can determine an object's distance, measure its speed, and even identify the elements it contains. In many ways, light is like a message sent across the cosmos. Some of those messages have spent millions or even billions of years traveling through space before finally arriving on Earth. The greater the distance we observe, the deeper into the past we are looking. Many of the galaxies we detect today no longer exist in the form we see them. Some have grown significantly larger, others have merged with neighboring galaxies, and some may have disappeared altogether. What reaches our telescopes is not the present-day universe, but a record of its distant past. Think of discovering an old family photograph. Everyone in the picture appears much younger. Children have grown up, homes have changed, and life has moved on. The photograph preserves a single moment in time rather than the present. The universe works the same way. Every image captured by a telescope reveals a different chapter in cosmic history. As astronomers compared observations from different periods of the universe's past, they uncovered an unexpected pattern. The early universe was packed with galaxies. Small galaxies were scattered throughout space in enormous numbers. Most were far smaller than the Milky Way, and many were only beginning to form. Across billions of years, gravity gradually drew these galaxies toward one another. Some simply passed by, while many slowly merged together. Over immense periods of time, countless small galaxies combined to create the massive galaxies that dominate the universe today. This is why the modern universe contains fewer individual galaxies than it once did. They did not vanish. They merged. For nearly 14 billion years, this process has continued. And even now, it has not stopped. These discoveries finally provided the solution to one of astronomy's oldest mysteries. There are three primary reasons the night sky remains dark. The first is that the universe had a beginning. Since it is approximately 13.8 billion years old, light from regions beyond the observable universe has not had enough time to reach us. Those galaxies may already exist, but their light has yet to arrive. The second reason is the expansion of the universe. As galaxies become increasingly distant, the light they emit is stretched to longer wavelengths. Eventually, it shifts beyond the range visible to human eyes. The light still exists and continues traveling through space. We simply cannot detect it with our vision. The third, and perhaps most remarkable reason, is that the majority of galaxies are simply too faint and too small to be observed with the telescopes available today. Thank you for watching. We hope this journey through the universe helped you discover something new.